Great.
I know how to pick this. We have audio.
Oh, we want video too. Yeah.
Now we have video.
All right, you and your demands.
I know. I need audio. I need the left channel and the right. We control the horizontal. So vertical. All set. Okay. Well, thank you everybody for coming. It's our first. We kind of tend to not do one in January. Nobody really wants to come out of their winter slumber at the very, very beginning of January. So we usually wait to February to kick off our meetup season. So if you're here, hopefully you know that you're here for the Utah Go user group. That should tip you off with our logo there. Couple quick notes before you go in. I don't do much, but I will say a couple of things. These little boxes above your head with the green lights, those are microphones, and they're directional and they're automatic. They're really, really good at zeroing in on you when you're speaking, even if you're whispering. They're in fact, they're designed to pick up, not whispers, but quiet talkers in a meeting. So you will, if you whisper, just understand you might show up on the recording audio, even if you're whispering, because microphones are really good. If you want to speak here, then you can, there's two ways. You can go to our paper call and submit there. That's kind of the formal way. The informal way is you join our Slack, which you go to forgeutah.tech and join Slack that way. It's the easiest way to get there. And you go to the Go channel and you just post that you want to speak at the meetup and you get hooked up at the right place. We're really broad. We want anybody that wants to speak, we want to give them time to speak. That's my policy and I'm sticking to it. You may not get the full time. We try to maybe fit smaller ones in or niche topics in to kind of group them up in like lightning talking sessions. But I want everyone that wants to come share to have a platform, come talk about Go. And I think I'm really happy about the one we're doing today because I think if you don't really want to talk about, one of the kind of big, and this still says 2024, but 2025 is here, and I'm keeping this same idea of I want to talk about the GoStdlib. Go is amazing in that it comes with the standard lib, which is not just batteries, but batteries and trinkets and tools and entire frameworks included. That's really cool. And there's a lot in there. No matter how much you've done Go, I guarantee you there's something in the standard lib that you don't know about, and probably a lot of things in packages you use every day that you don't know about. So I'm trying to really kind of cover all of the stuff in the standard lib. We still haven't even gotten a fraction of it done yet. We focused on it last year and I'm focusing on it this year. Doesn't mean we won't take other things, but I'm asking experienced speakers that are at the top in their field of niche topics and want to come talk about things like compilers and other things. I'm saying, cool, can you fit it in the context of a standard lib talk? Like, talk about the compiler? Awesome. Talk to me about the compiler while explaining the AST package in Go. Or there's stuff in Go that applies to every topic. So even if it's only tangential, it's enough that we can check it off the list of standard lib stuff that we're talking about. Ideally, you would do what Eric's doing today, and you would just come and just straight up have a talk that is about a standard lib package, because there's so many really cool ones. If you have 2 or 3 that are smaller, you want to put into one talk, that works as well. Last thing I'll point out, I know things are kind of hectic, but we do have 2 different channels in that same Slack. There's one for hiring and there's one for if you're looking for a job. So it's a really active community in both sides of that pipeline. So I would highly encourage anybody that is either trying to hire somebody or looking to get hired to post in their respective channels, or even just in the language channel and say what you're trying to do, and people will connect you to the right people. And that's it. So really, really plug in the standard lib thing. I'm really, really happy to have Eric here, and we had a talk a while back about it. He came up and said, I want to talk about one, I want to talk about the OS package. And there's a lot of cool stuff in the OS package. And I use probably 10% of it. So I'm really excited to learn a lot more about it from Eric. So I'll hand it off to. I'll also say, I've had this forever. Mariah gave me these ages ago. I got rid of all but one of them. I found one the other day when I was cleaning out my office. So that's going to be your gift, the speaker, as well as we giving you a license. So yeah, if you guys speak, I don't know if you can speak for the Go stuff. Yeah.
Yes, I am working the OS.
Okay.
So take it away, Eric. Thank you.
Thank you. I will say, as far as people who are on the edge or on the fence about presenting or not, mine will probably be the lowest of low, and it'll all be uphill from here. So I'll go ahead and set up the lowest baseline, and then you all can do much better. So share quick. Yeah, so, and I think I chose an interesting package where a lot of us use the Go OS package to some degree, I think, in our programming. There were some things that I did learn about this, and there are lots of things. Anyways, so this may be a very direct presentation, but I tried to make it a little bit unified, a little bit of discussion, so that we can have a good time. So yeah. So I tried to. Oh, let's see. Where am I? Oh, I'm on the. So I gave this presentation at my. Oh, I guess I should introduce myself a little bit more. I'm Eric, and I'm a software engineer at Vivint. So if you have smart home or Vivint questions, come reach out to me. I really like working with smart home stuff, whether that's like through already made devices like Matter devices or Thread whatever, and also trying to make my own through like ESP32 or an Arduino or something. My dream is to have just this fully automated house where I don't have to lift a finger to do anything. So when I got the Vivint job, it was kind of fun because I got to nerd out about smart home stuff while trying to work as well. Okay, so I wanted to kind of frame this because the OS package has a lot of things that you can do to sort of like do system level things in the Go programming language. So in reality, you could replace your bash scripts with the Go with the Go language if you wanted to, and you'll see that in the future or in the next couple of slides. But first, I kind of just wanted to go over like most scripts. They're probably in Bash. More advanced scripts are hopefully in something a little bit more manageable like Python. And this is to show that you can kind of create a quote unquote script in Go. I say quote unquote because scripts are compile time. They execute line by line, and Go has to be compiled before it's ran. So you lose a little bit of the scripting aspect there. So Bash is really powerful when you need something quick. You just need to string together some executions, some Bash commands, and take the output and the file or whatever. It's nice for small things, but I've heard many stories of many horror stories of 10,000 line Bash scripts that do complex data structures or data calculations, or at least they try to. And it seems like that the Bash scripting is not going to be the best for that. And it's hard to read. It can do some syntactic sugar to make your Bash scripts really unreadable if you think that you're smarter than everybody else. And also, if you want to use libraries, and I'm not entirely 100% sure of this, but I don't think that Bash has a way to use third-party libraries like you can with Go. Also, another con is like security. If you're taking inputs in your script, you probably want to do some filtering or make sure that you're not going to intake bad inputs. Sorry, words today. So I guess I've tried to make a thesis out of this presentation that like, yes, you can use Go to make scripts, and you want high performance and scalability. And if you want more parallelism, through like making Go routines or something. Something that I've learned is the difference between a process versus a thread. Process is in a new memory space and is a separate process, but a thread can be in a shared memory space, and then you can use your shared memory to do some calculations. Go has type safety and error handling, and you can use third-party libraries to help you out. So there's a fine line though. If your script is advanced enough, for not Bash, but maybe something in Go or Python or something, there may be a point where the script should be changed to an application. Does anybody have any ideas on when you think a script is meets certain conditions? Like, what are the conditions for when you gotta realize, okay, maybe this should be as a part of a service or something? Anybody have any ideas? Yeah.
My pretty bright line is as soon as you use arrays, as soon as you need arrays, you don't want any bash anymore.
Arrays?
Arrays,
Okay.
bash arrays are tactically a nightmare.
Oh, arrays. Okay.
Yeah.
I was like, arrays, like raising an error?
Oh, no, like arrays. Like when you need an array of something in bash, like which there is a syntax for, you probably want a better language or a different language, say.
Okay. Yeah.
My line.
Yeah.
If other people are gonna use it, or if you're gonna collaborate on writing it with someone else, then I would do Bash, like it's terrible. If it's very big at all, then oh my god, I got a space rock, I quit working.
It's kind of good for quick and dirty, but as soon as you need maintainability, it's going to be harder to manage.
How are you defining script versus application?
Well, I kind of had a hard time putting this together because it's like there's multiple ways that you could be like, maybe it's in a container that you can run, or just something like a service that you can hit with an API or something like, how do I take
But
this workload and automate it?
then I would say when you need it to run on another computer at that point.
Okay. Yeah.
I have a thought.
Oh, yeah.
My thought would be, well, I mean, not that anybody else is wrong, but my other condition would be, when it interacts with the database. When I am in the terminal, I don't like I'll interact with like a test database, but like for testing and stuff. But I don't like to run CLI applications on a database. I like it to be something that's been checked in and versioned. That's kind of my line. If it's a production database, the only code hitting it is stuff that's been reviewed by somebody else. I mean,
Right. Yeah. Awesome. I should also put out a disclaimer to everybody. I am hard of hearing, so if I hear arrays versus arrays, that's my fault. I do wear hearing aids, but I do miss things sometimes. Those are great responses, and it's stuff that I mean, some of these. For example, how often are you running this script? Who needs to run this? Are there persistent connections like a database or something that you should probably have reviewed? And how often is it changed or managed, like what was discussed? So I think we pretty much hit that out of the park. So it's good to keep that in mind for if you want to try to make a script or like in Go, but otherwise. So we're going to dive into the OS package now that I've tried to pull the pieces out of this library, standard library. The OS package is a platform agnostic, Unix-like way of interacting with the operating system. So as far as I understand, you could compile this for, Unix operating system or a Windows operating system, and it will have a consistent interaction method. And this way, if you interact with the underlying system and you have an error, you can handle that error to go away. So I think Go is kind of a model for good error handling and making sure that we do it simply and efficiently. So that's nice. And then as far as like versus writing a bash script, you know, you have things like environment variables, or I'm sorry, this is what's in the OS package. You can set environment variables in your scripting or your shell environment. You can arrange files and manage directories. It has signal handling, piping, and things, advanced things like temporary files. So we're going to dive into some of these, and I'm doing so. Okay. So I have a little game of this. Basically, I have the OS function, the package function, and I've tried to match up what you would use in a shell environment for this. So if you want to blurt out or raise your hand and volunteer of like what shell equivalent program you think this is or function, go right ahead. So most of them are pretty simple, so we'll see how it goes. So, yes, that's right.
We're all gonna give you bash answers. If you're waiting for PowerShell, I don't think you can get it.
Oh, no, I haven't even touched PowerShell, so I'm not an expert in that. So yeah, here, you know, here we can get the working directory and you can see the workings of my computer, and it's similar to PWD, so you can find out where you are in the system. So that's os.getwd. Changing directories, there's an os.chdir, and here we can see that run this, it changes the directory. The volunteers for what this is going to be in the shell?
CD?
Yeah, CD, cool.
Okay.
They don't have a way to have race conditions and not know which directory you're in the shell, I don't think.
It's called CD. It's the same thing.
No,
You
because
can-
I was making fun because in Go,
That function should never be called in any non-trivial Go script, right? Like that's put it there.
then every Go routine will be in a different directory.
Yes, it's.
Yeah, that would be an interesting to deal with.
I have actually reviewed production code that's like does that uses os.change directory, and I'm like, you have no idea what you've just done to like all the other handlers.
Oh, man.
So it is in there, but you probably should never use it.
Okay, yeah. Yeah, that's a big disclaimer. A lot of these functions, you know,
always
we should
lots of
use in
stuff, right?
production. If you have like, if you're trying to like traverse hundreds of files and doing, you know, actions based on them, you know, then that sounds great. Scripting. So again, I'm trying to attack like a very slim margin right here, like services, simple bash scripts, and then here's like some crazy Go only engineer that doesn't want to write in Python that is doing. Okay, so here is os.mkdir, and it makes a directory. And I already have it, so that's why it's erroring. But let's see, do this. Once.
You gotta kill the first
I'll
part.
put that, yeah, there you go. Floors. There we go.
Now you do it. It'll work.
Yes. So now I can run it again. Okay.
Oh, directory, not it.
Three non empty.
Do remove all.
That's right. Oh, yeah.
Yeah, there's your arm, that's all right.
Yeah.
it is.
There we go. Okay. So, yeah, a little bug. And I actually do have the make dir all and remove all in the next one. So, this one's really simple. I'm not even gonna ask. There's a make dir command in the shell. So, and then make dir all and remove all. There's something interesting here though. When I originally programmed this, let's see, can I just show my shell? Okay, so this command right here, this is what I intuitively thought, or not intuitively, but just guessed where if I do a make dir all, so like I want to create this sort of parent-child relationship with directories and then maybe delete them all the way through. This is not the way to do it, by naming the parent and all of the children, directories. When you do this, it only removes the last directory. So all you have to do to remove all is to specify the root directory, the root directory that you're trying to remove from. So this removes all. And
Dash P.
I'm sorry.
The top one, I think it's make dir dash P.
Oh, really?
Yes.
If you're doing your shellisms again, then that's make your dash P.
Okay, cool.
I don't know what the P
I
stands
didn't
for.
even attempt to look that up. So that was my bad.
All the necessary.
That's good to know, though. Make dash P does this. And I didn't really think of something to explain remove all in the shell because well, no.
RF.
Yes, RF. Okay. Well,
Wouldn't it be RM dir dash P?
No, not remove. Remove all is not directory specific. Remove all doesn't care whether it's file or directory at the other end of that. It will file. It'll remove that. If it's a directory, it'll remove that and anything underneath. There's no remove all dir.
I only do that.
right. Yeah.
That was.
Yeah. Cool. So forget all the words. Here we can create files. I'm sure we've all probably used this to create a file. And the file object is part of the OS package. So here we've created a file object and we can do actions on it. I thought I'd put this here because this is good to reference on certain permissions that you can put when you do open file. So create file obviously creates a new file. And I think if I remember correctly, if you try to do os.create and the file already exists, it returns an error. I can actually do, yeah, I'm just gonna. But if you do open file, then you can specify that you want to append to the file. And that way it won't error and you can append to it. So yeah, okay. Those are the shell commands. Surprise, surprise. The interesting thing about this, so I always have to Google like direction it goes in and stuff. I'm still early in my career. I'm still figuring these things out. But oh, there we go. I'll come back to the other slide. But that caret or that greater than sign is called a redirection operator. It's called redirection, and it's specifically for writing a file. And also, this is a great time to bring up piping as well, which is the vertical bar. And piping is basically on your left-hand side, the program on your left-hand side, that's program standard out will be piped into the standard in of the program on your right, which is really handy in shell. And there are some ways in the OS package that I will go over on how to do that. And this is mostly just for me to finally have a reference sheet for how these redirection operators go. And something I learned was that you can do a to caret and it will, you can put the standard error of your execution into a file, which is pretty nice. Okay, so that file object in the OS directory, you can do things on that file. So os.changedir will actually, or file.changedir will change the current directory to that file so that you can do operations on that file's directory for whatever reason.
That is a really weird one to include. Sorry, I didn't know that was in there. Why?
Yeah, but
Why?
that's the only useful way I could think of using changedir.
Yeah, but why would you ever want to like,
I don't know. I'm
Sorry.
just saying.
it seems superfluous. You could always just ask, figure out what directory it's in and then change to it. Like it's weird fit.
Not even that, just skip the relative path and everything and shit like that.
Yeah, it's not your, I'm learning something. That's cool.
No, yeah, it's, I considered not putting this in because it didn't really make sense, of like,
No, I
you
think
didn't have OS questions, or you can do the whole path of the file, like, you know, change the directory to file. Yeah, like relative paths are kind of dangerous. You kind of want to do absolute paths and at least that makes more sense in my head. You can change permissions. You can get the file descriptor. I don't know too much about the Unix file descriptor, but it returns an integer. You do file.fd. You can get its name, and then you can either read the file or you can read it at a specific byte offset. So you can give it a number and you can read the file after so many bytes. So if you're doing something like reading an encoded file for a WAV file or something, and you want to get rid of some headers or something, then you can say, okay, I know that the actual content happens at this byte, so I'm just going to jump to that. Reader allows you to just like read the other directory contents of the file, which doesn't really make sense for a file object, in my opinion.
I think that's the nuance here is that when you open that, it can also be a directory.
Oh, okay.
So
Gotcha.
Linux files,
It's just
everything's a
path.
file, including directories.
Right, okay.
So reader will work when the file handle happens to point to a directory. It will tell you everything in the directory. If it's a file, I'll just give you an error, say I can't read a directory, a file handle.
Okay. That makes more sense.
Very
Thank you.
confusing, old school Unixy stuff of like everything's a file and that gets weird sometimes.
Okay. Gotcha. I'm glad I included that. And I'm learning so much. I hope you guys are learning, but I think I'm the one learning the most this presentation. So you can write bytes to files, again, at a specific offset, or this is really convenient. There's a write string, so you don't have to, for your string to a byte array and then pass it along. So that's convenient for just doing quick things. Okay, so already went through that. And okay, here's the redirection operator. So this will overwrite a file, and then this will append to the end of the file. So temporary files. This one's pretty interesting. So when you do os.create temp, you can use the asterisk wildcard operator, and this will fill in that with the random string of characters. So if I run this right here, I didn't specify a directory, so it specified one for me. You can see right here in the file name, it created a temporary file and it ensures that it's unique to some degree. Does anybody know what shell command is, if there is a shell command to make a temporary
I'm
file?
sure there's one called mktemp.
Okay, yeah. And you guys are more smart than I am. Because I was like, looking this up and I was like, whoa, that's cool. And you can, in mktemp, you can actually, I'll look that up. You can specify with X's, I think, and it will also fill that in with random, with this -t.
Will that just put it in the temp directory then automatically? Yeah. Does it tell you the file path on create?
I just know it exists. I've not used mktemp much. I've used createtemp a lot.
You have to know like where
This also isn't a shell command. This is a system command. So it's not like from bash or anything, like you can use it on anything or without a shell entirely. But the problem is like, it's not cross-platform, whereas the OS create temp will work on Windows.
It's true.
One of the huge things of createtemp is it does a lot of work to make sure it's unique. So os.createtemp, not just random string, it is like concurrency. You could run it and you do it as part of an HTTP handler called by a ton of things at the same time, and they'll all get their own create. So it's a lot safer than just random.
Okay. I assumed it was something like that, but I didn't want to throw out any guarantees for like, you can do this in concurrency, but. Okay, so, yeah. Awesome. Yeah, and. Yep. Yeah. So, an interesting thing about the using OS.open is, there's a vulnerability. If you don't sanitize your inputs or whatever, and you accept a user input for, and then like open a directory for that, then they can backtrack and access other files in your operating system. So here, I can go backwards and let's see. Okay, so if I run this, then I get hello, but I've also got this hello.go file that I don't want anybody to read from. It's super secret. But here, even though I'm not in this directory, I can go back, I can go wherever I want, basically. I'm sorry, words are hard to come by when I'm standing in front of people.
No, you're doing great.
Totally fine.
Yeah. So one thing that's really cool that's coming out, I think this month in Go.1.24 is that there's a root object that you can use. So when you do os.open root, you can specify a directory and then run methods on that. So if you try to run root.open and try to backtrack to that, my super secret program right here, it actually spits out error. Oh, and I can't run this because I did have 1.24 on my computer, but then it was causing me problems on my work stuff. So
The release candidate.
I went back to 1.23.5. But if I did run this with 1.24, then it has a nice Go error format stuff that says like unauthorized or something like that.
They're in the this is actually really cool because they have file system stuff that makes it seem like you do this, but they have big warnings in it that it's not actually fully backtrack safe. And there's some stuff for like you can kind of get away with it now with filepath.clean, but it's not really guaranteed in every scenario to protect you from backtracking. So that's cool.
Yeah,
They're adding it to OS now.
yeah. Kind of fun. I can advertise a new feature in 1.24. So yeah. Let's see what else would that present in here. Oh, this was something interesting though too. I was like, I wonder if they're looking just for like the 2 dots to go back at their something. But when I do this, it doesn't throw an error because it knows that I've like gone back and then gone forward with the same file, which is interesting. So it's not as easily fooled as my experienced brain can think of. So yeah, that's that. Okay, this is going to be a super difficult one. CH mods, changing the permissions of a file. I'm sure none of us know the shell command of this. It's CH mod. So, okay, environment variables. This one's interesting as well. So now we're into the cool stuff. So, at first, I mean, you can set environment variables. So here, I run set env, so I can take an environment variable, give it a value, and I can also look it up. So lookup env is how you can look up your system's environment variables. So that's pretty cool.
So question,
Yeah.
does anybody know, does this have the same problem that CHDir does where when if you set it and it switches go routines to a different process, it would read a different environment variable?
That's how Linux processes work, is that process has an environment that is for the process. So you only,
What I meant thread, not process. That's what I meant. I meant to say thread.
it's all shared. So
Okay, so it'll work. So it doesn't have the problem that CHDir
it's
has.
the same, no, it does have the same problem.
It does have the same problem that CHDir has.
Do not set the environment
After.
pretty much after like in any handlers or anything, you only ever want to set it. Like you could set it during a init if you needed to. You almost never need to set. 99% of the time, I think use case is to read, but it is like shared amongst the whole Go process, like everything. Every routine, everything's gonna see the new variable.
ENVs, just gonna go through that quickly. Expand ENV so you can, expand ENV into a string and it returns a string. So when I run this, it inserts the environment variable that I've created in there. Or systems environment variables that exist. So that's pretty
Oddly
nice.
specific function, like to have it all.
Right. Like
Yes.
this,
Yes.
insert.
My guess is it's used a lot internally, like when they're doing stuff like to like plumb together like builds in Go. Like, so
Oh, yeah.
they were like, we need this a lot when we're building Go for our tools, so we're gonna put it in here kind of just for us.
Yeah.
I used it in like 3 places. I will admit, like there's a couple places where it was really nice.
But it is very,
It's very niche. I will
Just
say,
wait.
you should go back, if, you may be gonna cover this, the difference between lookup ENV and get ENV.
Oh. My brain completely blanked on that. I
Okay.
didn't see yeah.
Because at a glance, they look the same.
Uh,
Except their function signatures are different. So get ENV only returns a string.
I was gonna say it doesn't have the okay, just check that it exists.
Yeah, it'll just return empty string if it's not there. Whereas lookup gives you that second variable to say, I found it. It was empty, but it was set to empty string, which is different in Linux Unix land. From
Right.
you never even set this variable at all.
okay.
It's a really niche also difference, but can matter sometimes.
Okay, yeah. That makes sense. Cool, thanks.
Yeah, okay.
So this one's interesting. There's an os.expand, which is similar to expand ENV where you can have this special, forgot what to call it, just this special case, but you can pass it a function and the function signature is that it receives a string and then it returns a string. So you can switch or run conditions on that string and then return some sort of response or do whatever actions you need. So here I've done that. So I've specified this, it looks it up and returns something. So I guess this could probably be useful in like, say you want different environments or something and you can programmatically specify that.
Little micro templating language for almost no reason. Well, and you can see how that os.expand env is just this, where the function is os.get env.
Yes.
Like if you just pass, instead of get env, if you pass os.get env, that's all expand env is doing behind the scenes.
Straight up.
Very silly, but
Yeah, that's cool.
Also weird that it's in the OS package rather than say font.
Well,
I guess because it's intended to work env variables that are.
It's because
Shell
it's
syntax.
in OS, yeah, because it's meant to be run as bash.
It's awesome. It's just very
it's very fun to like, for sure.
Well, you always can't depend on anything else. It goes back to you.
Oh, that's a good point. Yeah, it has to be completely self-contained.
So, these are a few other ones where you can get your process ID or your parent process ID. And also you can get your command names or any other arguments that were specified in your runtime. I'm sure a lot of people probably use this for Go stuff. So,
OSArgs is the pure Go way of doing CLI subcommands.
I'm sorry, what was that?
It is the pure Go way of doing CLI subcommands.
Okay.
So if you were to do, make a CLI application, you would have the OSR one would be your subcommand essentially.
Right, okay.
So if you were trying to not use a CLI helper library, you would be able to use OSArgs for that. I'm not saying it's helpful because you do have anytime you're required to something to be in a location that a user gives you, like ordered locations based on user, I get scared. So I wouldn't do it, but that is technically, if you're making a CLI strictly GoLib, that is how you do subcommands.
Yeah. And this is definitely not the correct way. I mean, it is correct, but it's like, there's so many nice libraries that you can specify arguments and it'll like compile it all for you and give you a nice help.
At least of which is the flags. We haven't had anyone talk about yet, so if you want to come talk about the flags package, there's a plug.
It's amazing. Well, I already I can, whenever you're ready, Carson, I have the demo too.
Yes. Like I said, it's all uphill from here. Okay. So I thought this was interesting. I didn't know that you can, that the current process was. Okay. Any wild guesses on what this code is replicating as far as a certain shell program? Sorry?
LS.
LS, yeah, great. You get points. It's the show where everything's made up and the points don't matter. So, yeah, so I thought this was pretty cool. So here I can see my current working
And
directory
you can
for
get it ordered.
my space station.
Was that a whose line is it anyway reference?
Yeah, yeah. You get points too, 1,000 points.
Excellent. 90s moment, man.
Yeah, I love it. Whose line is
Oh, really?
Yep.
Oh, dang, I gotta get cable or something.
Yeah, the new one's not as good as the old ones though. Yeah. Okay, there's a few things I wanted to touch in, seems like sub packages of OS is, if that's the right way to call it. So exec, is you can run, shell commands or other program. You can run the external programs in Go. Here, so I wanted to specify the difference between run and start. Run basically, it waits for the process to finish before it continues the program execution. And rather than having to actually do like a Go routine or something, you can actually just do cmd.start. And this is a non-blocking statement, so you can continue forward. And you can do cmd.wait if you're at a point in your code where you need to bring that or wait for that CMD to finish. So if I run this, it's still waiting. But if I comment this out, then it goes right away. But the command is still running in the background, I think. So yeah. Oh, oops, there we go. You can use the ampersand to run processes in the background for shell environment. Okay, piping. This one's cool because you can pipe. We've already gone over piping. So here I'm writing a string to standard in, I think. Right? Yeah. Okay. So I'm specifying an output for a certain standard in, and I'm running cat on it. So cat will receive this and display it. So the result of the code is not very interesting, but it's the program is. So I'm basically using cat and taking this standard in and displaying it. So that's pretty cool. And I also did the same thing for standard out. No, okay. I just did the equivalent right here. I've kind of given up on my game because it's too easy. Okay, here's the standard out. So here I'm echoing some JSON and I'm grabbing the standard out and I'm using a JSON decoder to put it into a struct. It's not shown here, but I have a struct that I'm putting to, and then I'm printing name and age. So if I run this, Bob is 32 years old, which we see correctly is displayed in the JSON text. And you can use JQ to kind of achieve similar results. So os.signal is nice if you do shell scripting and stuff, you probably handle signals, you know, if somebody does control C or if another program gives a signal, then you can handle signals, like an interrupt signal, you can grab, that's not the right signal. Oh, well, so yeah, there's os.interrupted, os.kill. Yeah,
That's actually super useful. That's like
I-
shorthand for, I'm gonna start a thing and I will wait till you do control C or try to kill it through a process manager or whatever before it stops. Like,
The other
Right.
thing too, you
Really
can do with that channel is if you get notified on that channel, you can do safe shutdowns. So you can make sure all your Go routines close in a certain order. I've had multiple programs where we've opened Go routines, you do a control C and you're like, why didn't it stop? Because you have to control C every Go routine. And so using very regularly, well, when I remember, to use signal notify, that's what I use that channel for specifically, is to make sure all my Go routines close when I do the control C instead of having, it's a pain to have to control C more than once.
okay, so you basically specify like a certain number of channels to,
So that right there is the buffer size, right? So I only want one signal in that channel. As soon as I press control C, I want to trigger the stopping process. So I'll trigger whatever shutdown functions I have and whatever context done needs to be passed, whatever cancel functions need to be sent will all get triggered as soon as that S is populated, essentially.
I've seen something really cool with this because I'm impatient people and I saw this in like kubectl or something. So you do this normal thing and then after you read, so after that first S : equals, so someone hit control C once, you pulled off the channel, you started your long, slow shutdown process, and then you spin off a Go routine that reads from the channel again.
In case it has to force.
So the next control C, you just os.exit. You say, first control C, I'm gonna start my slow shutdown, I'm gonna print it out, but if you do it again, we'll
It's a
like,
force shutdown. That's cool.
we'll let you kill it without.
I noticed something like that the other day. So I was like, why did you do it on the first one? The second one, I was like, no.
Yeah, they're pretty common because people just get patient. Hold control hit C a bunch of times, and by people, I definitely don't mean me.
Well, I do it if it doesn't stop after the first one,
It's like, I told
within
you to
like
die,
a
you
second
died.
or two.
Yeah, exactly.
so in the second control C, does your shutdown function still continue or does it just like?
OS exit,
OS exit.
OS exit cuts everything off.
Okay.
Yeah, that channel will get events for every one of the signals you subscribe to. Like interrupt is just one out of like 20.
Yes.
My question is, all of the examples I've seen for signal notify use a channel size of 1 is where I would have expected a buffer. Does anybody know why that is?
So the reason it does it is essentially it's blocking. It's saying if we have one in the channel, don't. Oh, it's processed. That's the only reason why. So Carson can hit control C as many
Oh.
times as he wants, but until S is populated, it's not going to list it.
Okay, so it's,
That's it.
so it wants back pressure, but not on the first try.
I don't know what the implications would be on the OS, but it's essentially just to say, yeah, I don't need to process all your spam.
They just get queued up.
Yeah.
I mean, it's
Yeah.
just like characters in a buffer, like they're queued up and they'll still be there if something listens for it, but if nothing's listening for it, then.
Yeah, pretty much. It's just not listening anymore once it's full.
Which could mean if you don't do control C first, if you did something else and had a long process on that signal.
But it's only gonna listen. That's only subscribed to controls, right?
It's like you did it off on a routine.
Be really nefarious with this, can't you?
We do the cool stuff. We'll say, we use a version of this, but we use quick. So there are two, maybe three, but there are two big ones I know of. Control C sends interrupt. Control / will send sig quit, which by default in Go will it kills your program, prints a stack trace of every Go routine that's running. So if you're like, this Go program is not responding, I don't know what it's doing, I have no idea, it's not listening to me, control / it will print everything it's doing and die.
As that now.
That's nice.
Very, very
Still nine.
I think it's just the same as panic, right?
It is,
And it's what?
it's sort of, it's not the same as panic, it's like a full every thread,
The full stack
not just
trace.
the current one, it's like every thread,
The
every Go routine.
Corda. Oh, yeah, Corda.
It is a core node. Yeah, it's basically a core node. But you can catch that instead. If you don't want that behavior, you can, and we actually do this in our developer tool. If your service is running, we use a tool to start our services. You use control / we intercept that instead and restart your service for you instead of killing the process. So,
How many
How am I
developers
supposed to
that we
see
know
the
that's
stack
there?
if you do that?
you know, that's a different problem. That might problem. Need to see the stack.
That's cool.
So anyway, there's some fun stuff. Not too nefarious, but there's fun stuff.
Yeah, that's great. I think I just have one more. Always user, basically look up user information.
Check if you're root.
Yeah.
I mean, that's the obvious use case.
Process I'm talking to.
Yeah.
We,
I think I've already gotten this question answered of like, what do people use the OS package for? It seems like people have done really great things. I almost thought that like, maybe I should make some sort of esoteric game where it's like tic-tac-toe, but it writes files and does some complex things with your operating system, but I didn't have, I end up, I had the time, but I didn't. So I think that's all. Yeah, thanks, everybody. Any questions?
first.
Yeah.
I'm just curious if you have any more, I know that it's a Unix-like interface to your operating system. Have you done much with the OS package on Windows? Like, I know there are some compatibility weirdnesses and some problems there.
I've quarantined myself away from Windows. So,
Good idea.
I,
It works
Yeah.
the same on Windows because they don't expose the Linux and BSD specific APIs and syscalls. So you'll notice like birth time is not present in file metadata because they're being compatible with both Windows and Linux.
So how does it handle things like permission bits and stuff?
The permission bits on Windows can be represented kind of similarly,
Okay.
but
So it just maps it over.
and what it can do just gets ignored.
okay.
They're pretty good at calling it out too. So like that root package, when Goose's Windows names may not reference null or com1, Goose's JS root vulnerability to talk to like every little difference they do often call out in the docs because someone will run into it like, why did this happen? So like,
Yeah,
They're pretty good about calling it out.
I do remember that they did document some like alternative. I just turned a blind eye to it. Sorry about that.
That's fine.
While you're here, one really cool thing, if you click on, next to all of these blue names of the functions, there's a little parenthesis, click on that, it'll take you to the code. Actually,
just click on the blue
click
name.
on the word, that's right. Just click on the, like,
Click on the name, yeah.
there's a really fun thing in here illustrated a lot in the OS package, and if you look on the left at like dir or any of the, notice how many of those are with the same prefix with an underscore. The Durant, Linux, NetBSD, OpenBSD, those are build tags, right? So like,
Those are all the operating systems that Go supports.
yeah, those aren't arbitrary. Those are like,
Yeah.
if you're building for Darwin, then only the dir_Darwin files will be included. So like, you'll see duplicated types and function names between every single one of those dir underscores for different, like, so right here, it's
Why don't I see build text?
And if you look at dir Unix,
the file
Oh,
name
it's
uses
their
dir.
magic wand.
it has the actual build tags
If you
Yeah,
show up on line 5.
It'll pull
Line 5.
that interface.
Line 5.
It's technically the exact equivalent of having it called.
So this is the same as all of those are the things that you would have to name this file if you wanted all of them. So Unix is not actually a build tag, but it's
compile because it could be like
anything that's arbitrary. If it's a build tag, it matches. If it's not a build tag, it looks for
all day.
it'll find.
Gotcha. That's cool.
Yeah, that's a good example of Go build.
Oh, I used a thing that just straight up doesn't exist in Windows. So
JS and WASM. Is there another JS?
No. JS is WASM. So when they're compiling to WASM, they use the JS build.
It's just interesting.
I'm just
because it
saying
did
they're
an and.
they say and, but it's because that's literally the flag. Like if you say go for
Text is a whole
JS
talk.
or
It's
like,
just interesting. This is a good, there's so many files in
like
here.
if you
But
like
that's not an,
OS.
that's not an, so it's,
no
it has to be WASM that's JS or WASM
Painter works
WASI
on Linux.
is JS, but it's saying it can't be JS and WASI.
Yeah, and it does on Windows because
they only go to us.
code it up.
I think
WASI?
JS and WASM was the precursor to WASI P1, which will then become WASI P2, which will eventually become something else. But when they started, they split across two of them or something. And so you have to use both to actually get into the mode that's I want JS, but Unix variant JS, whatever that is. So that's I believe that was the precursor to WASI.
It's like architecture. It's like I want Darwin, ARM64. It's I want JS, WASM.
They did what JavaScript has always done, which is they fork framework so quickly that eventually they just said, all right, we're going to
Always
keep their build tags instead of trying to figure out
If that was,
how to keep up.
Yeah. Yeah, so I'll talk about that. So anyway, yeah. Any more questions? I don't want to make them stand up here as we talk amongst ourselves. Down, talk amongst the normal.